This is our second stock valuation unit, and this one will deal with the infinite model. So our goals for this unit are to understand the theory behind the infinite model, describe some of the strengths and weaknesses to the model, and develop a pricing equation. And we'll do an example at the end where we price a stock using the Gordon growth model. When we talked about the finite model in our last lecture, we said a big weakness of the model was assuming a future selling price, and we needed to make an adjustment. With this infinite model, we assume that you hold the stock forever, so there is no assumed selling price. And if we think about this, this sort of makes sense because remember when we talked about the corporate form of a business, it features unlimited life, right? Ownership can be passed down from one generation to the next. So we think then of the infinite model as pricing a stock as the present value of all future dividends. And we just assume the dividends go on forever. If we look at the equation, you see it's a cash flow stream where we discount every dividend one at a time. You see we go years 1, 2, 3, out to year N, and then we just keep going all the way out to infinity, wherever that might be. Now to solve this is really impossible unless we make some sort of assumption. And the assumption we have to make is that all the dividends are linked together by a constant growth rate G. So if I know the dividend today, I know the dividend next year would just be today's dividend times 1 plus G. And we can link every one of them in that manner. So we substitute in our equation and we get the following. Our infinite cash flow stream reduces to the simplest equation we'll use all semester. It's just next year's dividend divided by R minus G. And you see an alternate equation where we take today's dividend and grow it one period. Well, think about what that means. If I grow today's dividend by one period of growth, that just gets me D1. Okay, so the two equations are the same. So the variables in this equation, R is the required return to hold the stock, G is the constant growth rate in dividends, and we have to have it where R is greater than G. So in other words, investors want a larger percentage return than the growth rate in dividends. Now mechanically this has to happen, otherwise we get a negative price, and we know that can't happen. So let's look at a simple example to close out this unit. Stock A just paid a $4 dividend, so that would be D0 in our terminology. And dividends have an estimated growth rate of 2%, a market discount rate of 8%. What is the current price? So we'd simply say $4 times 1 plus G, so 1 plus 2%, so that relates as 1.02, divided by R minus G. Well, R is 8%, G is 2%. Notice we write these by hand as decimals. So our selling price today, or intrinsic value, would be $68. Well, obviously there's a huge weakness created here. We get rid of assuming a selling price, but now we're assuming a constant growth rate in dividends, which is a weakness in itself. So we have two models, and two models with significant flaws. So how can we get around this problem? Well, what we're going to do in our next lecture is combine the finite and infinite model into one pricing model that tries to address the weaknesses of each model that we've discussed so far. It's not going to solve all our problems, but it'll be a more realistic or stronger model than what we have at this point.